Hello everyone, welcome to my channel Physics Tricks. So in this video, I'll be taking a motion in a straight line short tricks, right? And these type of problems you can solve within 10 seconds if you know the concept behind it. So I'll be firstly telling you the theory behind it, right? Like how to take all the equations, right? So three equations of motions are there, right? These equations, how to take, how to handle the problems behind this, everything I'll illustrate in this video. So let's get started then. So we have uniform acceleration, right? So for uniform acceleration, we know that three equations are there. V is equal to u plus at, s is equal to ut plus half at squared, v square is equal to u square plus 2as. So see here, and I'm taking this two types of problem over here, right? Like if they give in any problem, suppose a particle or a body, an object, anything, right? A particle, a body, an object, if they give is starting from rest, that is it is a release supposed to be, right? For a freely falling body it is released. If it is starting from rest, if I throw a ball upward at the topmost point, velocity is 0. So whenever we have the velocity is 0, right, at that point you can convert these three formulas into v is equal to, instead of u you have to put 0, v is equal to at, t is equal to v by a, s is equal to half at squared, t is equal to root of 2s by a, v square is equal to 2as, s is equal to v square by 2a. So that means 6 formulas which we have. For time, 2 formulas; for velocity, 2 formulas; for displacement, 2 formulas, right? So you have to remember this so that you can apply in the problem directly, right? So for that, yes, prerequisite is required. You have to be thorough with this topic, right? And then and only then you can apply this trick. Okay, so for uniform acceleration, if a particle is starting from rest and at t time we wanted to calculate what is that t, right? It is v by a, whatever the final velocity is there divided by the acceleration will be the time. Whatever, if you want the final velocity, it is the acceleration times the t, or else root of 2 into a into s. If you want the displacement, we have two formulas. One is half at squared, v square by 2a is the second formula. So for time, for velocity, for displacement, there are two formulas. So in all, 6 formulas are there. Okay, now one more interesting thing about these formulas are, these formulas are reversible. Reversible means what? If I gave the initially, right, in question, if they gave supposed to be initially the velocity is u but deceleration is there, that means final velocity we'll have is 0, isn't it? Somewhere at the some point it will have what is called as the final velocity 0, right? From that time t we can actually apply the same equations, right? Instead of v we have to put u, that's it. So time is equal to u by a, whatever the initial velocity is there, divided by the acceleration, right, which is equal to root of 2s by a, u is equal to at, which is root of 2as, s is equal to half at square or v squared, that is u squared divided by 2a. So if you know that replace with u, you can actually find acceleration, you can actually find time, velocity, displacement within a second, right? I'll take illustration, I'll take examples, I'll take questions, so don't worry about that, right? Now how to solve? Okay, so most of you might have the doubt, right, how to apply this formulas, how to apply this equations into the questions. I'll tell everything, so stay tuned. Okay, so now I'll take first question. As you can see over here, now it is given one car is there which has an initial velocity u is equal to 40 meter per second and the retardation of 4 meter per second squared. You have to find what is the stopping distance of car. What does stopping distance mean? The distance traveled by the car from the initial position to the final position where its velocity is 0. Time to stop. What is the time required for the car to stop, right? Its final velocity must be 0 then. Okay, so now for that case, we want firstly stopping distance. Stopping distance, you can use half at t squared or else v squared, that is u squared divided by 2a. Right now, v squared or u squared divided by 2a. So over here, u is given, acceleration is given, directly stopping distance you can calculate, and that is s is equal to u squared divided by 2a, which is u squared is 40 into 40 divided by 2 into a is 4. If you just calculate this, you will get 40 into 5, which is equal to 200 meter. This is the stopping distance. See, here you can calculate this within a second, isn't it? And then second one, we have time to stop. What is the time required for a body to stop, for a car to stop? For time, we have u divided by a. U is 40, a is 4, which is equal to 10 seconds. So see, if you know this formula, right, t is equal to u by a, which is equal to root of 2s by a, u is equal to 8a, which is equal to root of 2as, s is equal to half at t squared, which is equal to u squared by 2a. If you know these 6 formulas, you can actually solve the problems within a second. So I'll suggest, try to remember with these 3 equations, right? V is equal to u plus 8a, s is equal to ut plus half at t squared, then we have v square is equal to u square plus 2as. Try to remember these 3 formulas, right? What is that? T is equal to u by a, which is equal to root of 2s by a. U is equal to 8a, which is equal to root of 2as. S is equal to half at t squared, which is equal to v square by 2a. So try to remember. I'll assure you that you can solve, right? You can solve the problems within a second. Sure. So next problem we have. Now the next problem. One man is there. He throwed a ball upward with some initial velocity u, right? With some initial velocity u, and that is equal to 20 meter per second, and acceleration due to gravity is given 10 meter per second squared. Maximum height of the ball. Now we know that at a maximum height, final velocity is 0. Whenever velocity is 0, you can apply these formulas. Whenever velocity is 0, you can apply these formulas. So maximum displacement we want, maximum height we want. So over here, I'm solving this. Maximum height, you can have formula as, that is s, right? Displacement, maximum height, v square by 2a, that means u squared by 2a. So what is u squared given? 400 divided by 2 into a is 10. So you can have this as 20 meter. 20 meter. Okay, now so this is the maximum height. Then what is the time of flight? Time of flight is the time required for a ball to go up, that is time of ascent, and come down, that is the time of descent. And we know that time of ascent is equal to time of descent. So time, we know the formula, time t is equal to u divided by a. And just now we have seen this is u by a or root of 2s by a. You will get the same answer. So what is u? 20. What is a? 10. So which is 2 seconds. Now if anyone wants, why can't you use 2s by a? You can use 2s by a. 2 into 20 divided by 0, 0, 0 get cancelled. We have what is called as 2 seconds. So see here, if you remember these formulas, it will be very simple, right? So this is the second answer we have. So I hope this is clear. Next, see here in this it is given, find time taken by ball to hit the ground. So here the question is given, one man is there which is on the top of a building of height 100 meter. He throwed the ball upward with a velocity of 20 meter per second, right? We have to find the time taken by ball to hit the ground. So what is the time required by this ball to hit the ground, and velocity of the ball at the ground? Okay, now we can split this into the 2 part, right? When this ball is going upward at the maximum height, its velocity will become 0. That means for a ball to go up, final velocity is 0, initial velocity is 20 meter per second, right? So this one, we have height supposed to be h1. Height supposed to be h1, right? And then this ball will come down. And for that, initial velocity is 0. Initial velocity is 0. Final velocity we want supposed to be. So find the time taken by ball to hit the ground. So to go up, it will require a time t1 supposed to be, and to come down, it will require a time t2 supposed to be. So we will calculate now h1, t1, t2, right? h1, t1, t2. h1 how to calculate? it is the displacement, maximum height we have, displacement of a body to stop, we can say, right? Stopping distance, we can say. So S is equal to, we can use V squared divided by 2A, which is equal to V squared as in U squared 400 divided by 20, which is equal to 20 meter, right? So this is the H1 we have. That means this ball has to travel a total distance of for coming down, it is 120 meter. It is 120 meter he has to travel. So what is the final velocity? Final velocity is root 2as, which is equal to root 2 into 10 into what is s over here, 120. So if you just solve this, you will get this as, this is 10 root, this is 6 into 4, so I think it is 20 root 6 meter per second. This is the final velocity. Now what is the time, right? So this is the second answer. Time is very simple now. First answer, time t1 will calculate, it is u divided by a, 20 divided by 10, which is equal to 2 seconds. And t2 we can calculate, it is what is called as root of 2s by a, which is root of 2 into s is 120 divided by a is 0, so 0 0 get cancelled, will have 2 root 6. So total time, therefore total time is equal to t1 plus t2, which is 2 plus 2 root 6, that is 2 in bracket 1 plus root 6. Now see, it is very simple, hai na? Now why to use what is called as s is equal to ut plus half at squared? Then we'll get one quadratic equation, and that quadratic equation has two roots. One of them is negative, so that's why we didn't take. Why to take that? See here, it will take hardly 10 seconds to solve this problem, right? Within a seconds you can solve these type of problems, right? But yes, for that you need to be thorough with kinematics theory, right? Kinematics theory. If you want, right, kinematics theory, you can go into the description, you can click on the link and you can actually watch that video, right? That is kinematics in one shot. I gave that video. Chalo, so next problem we have, and in this problem, as you can see, with what speed boy B has to run to catch the ball which is released by boy A. So boy A releases this ball, and which is at a height of 125 meter, right? 125 meter. So with what speed this boy B has to run so that this boy B catches this ball released by this boy A. Chalo, so now see, what is the time required for the ball to come down? It is initial velocity is 0 given. It's very simple now. T is equal to, we have root of 2s divided by a, which is equal to root of 2 into what is s over here, 125. What is a over here, 10. So which is equal to, this is 250 divided by 10, which is 5 seconds, right? So over here we time required is 5 seconds. Now okay, no problem. Now in 5 seconds only this boy B has to run towards this pole or the building so that he catches this ball. So what is the speed? Speed is equal to distance by time. So distance he has to travel is 60 and time is 5. So he has to run with 12 meter in 1 second. 12 meter in 1 seconds. So I hope this is clear. It's very simple if you go with the basics right now. Chalo, next problem, it is given now. Now in this question it is given, while penetrating the plank, a bullet loses 1/10 of the initial velocity. Okay, so 1/10 of the initial velocity as in what? So final velocity we have from the one plank, if it passes through the one plank, final velocity it will have is u minus 1/10 of u as in u by 10. So 9u divided by 10. So how to find deceleration? Let us consider the thickness of it is t. So the deceleration we can find acceleration a is equal to final velocity squared, that is 81 u squared divided by 100 minus initial velocity squared u squared divided by 2 into s, that is 2t. So if you just solve this, you will get minus 19 u squared divided by 200t. So this is the deceleration, acceleration we have. Now number of planks that we have to add, so that the bullet will have the final velocity, and that final velocity must be 0, right? So number of planks that we need to add. So let us consider n planks we have added, so that initial velocity of the bullet is supposed to be u. The final velocity of the bullet through this plank must be equal to what? 0, right? Final velocity of the bullet through this plank must be equal to 0. So whenever velocity is 0, we can apply this. So s that is n into t, right? The displacement we have is n into t is equal to initial velocity u square divided by 2 into a. We have calculated minus 19 u square divided by 200 t. So this is u squared get cancelled. Then n into t is equal to, we have minus, and this minus will have plus, it will become deceleration, no? So it is plus, so you will get it as, this is plus because a is deceleration, not the acceleration. So we have, this is 100 divided by 19 into t, so t get cancelled, so n is equal to 100 by 19. So as you can see, this is greater than 5 now, greater than 5. So greater than 5 indicates the number of planks required, to stop the bullet is what? N is equal to 6. So if you take 5 planks, the bullet will still have some velocity, but we wanted to stop it, so we have to add one more plank, and that is 6th plank we have to add. Okay, so this is the answer for this question. Now next question we have, and it is given this is the parachute, and man inside this parachute, it is moving upward with a velocity of 10 meter per second, and he releases this stone. Means what? He doesn't give any force to it, or he doesn't give any external velocity, right? So that it will move upward with some velocity, right? As this parachute has velocity of 10 meter per second, the stone will have the velocity of 10 meter per second in the upward direction. So what is the motion of the stone? So motion of the stone will be somewhat in this manner, right? Stone is at a height of 100 meter. So it will move upward with a velocity of 10 meter per second. So it will move upward and it will stop somewhere, right? Final velocity will be 0, and after that it will come down and it will hit the ground. So you can calculate the final velocity, you can calculate what is the maximum height reached by this ball, you can calculate what is the time required for this ball to hit the ground. You can apply the same equations, and you can comment in the comment box what are the answers. I'll try to reply to your comment as soon as possible. So I want over here h1, I want what is t, total time. This is t1. If you consider, let us consider this is t2, right? T1 is like from up to bottom. I want total time, that is t1 plus t2. I want h1, I want, then velocity, I want velocity v, it will hit the, to which that ball will hit the ground, right? So all of you try to solve this question, comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.